So we want to solve a first order differential equation, and like usual we want to put it in standard form. So that means the y term needs to be on the left side, or at least it needs to be with the derivative of y term. And then for standard form we need the derivative of y by itself, so I'm going to divide everything by x. So it's like a 1 over x here. Now we got it in standard form. This is our p of x, and this is our q of x. So to find the integrating factor, m of x, as our text defines it as, our integrating factor is going to be e to the indefinite integral of p of x, negative 1 over x dx. So if we evaluate that a little bit more, you can factor out the negative sign. We know the antiderivative of 1 over x is natural log x. Or equivalently, that's e to the natural log. We don't like to have a negative sign on the outside. That way we can cancel out some terms. This is x to the negative first here, or 1 over x is probably an easier way of writing that. And now e to the power of natural log, an exponent base e and a natural log, those are inverses of one another. So we have our integrating factor. It's 1 over x. Okay, so now that we have that, we can use what their textbook gave us to find a solution to a first order differential equation. Y is going to equal 1 over x. So an easier way of writing that is just x. And now it's the indefinite integral of our m of x times our q of x, which is just negative 3. There's no x there. There's our arbitrary constant. So y equals x times, now we know this antiderivative, right? We move this negative 3 to the outside. The antiderivative of 1 over x is natural log x. And then we're going to have plus an arbitrary constant when we evaluate this antiderivative. There's an arbitrary constant c that comes out of it. We'll distinguish that. Actually, it doesn't matter at this point. Yeah, so just one arbitrary constant. The reason is because we do get an arbitrary constant out of here. You're going to multiply it by negative 3, and then you're going to add it to another arbitrary constant. So an arbitrary constant plus another arbitrary constant, still just any old arbitrary constant. And now we could distribute. I mean, I don't know. This is probably fine. There's another way we could write it, though. I think this is probably what our textbook and what WebAssign does. Okay, that's our solution. And we could check to make sure it's a solution. We could find out y prime, plug it back in, make sure the equation makes sense, make sure the two sides equal each other.